What is scientific notation? How to convert scientific notations to numbers? How to convert numbers to scientific notations? Scientific notation is a simple way to write and keep track of large and small numbers without tons of zeros. It offers a shortcut way to do calculations and record results. The SI measuring system is based on a decimal system with calculations written in groups of 10. Results can be easily recorded as exponents of 10. Written superscripts indicate exponential values. In 1670, a French scientist named Gabriel Mouton suggested a decimal system of measurement. Units were based on groups of 10. It took a while for people to try for themselves, but in 1799, the French Academy of Sciences established a decimal-based system of measurement. They call it the metric system, from Greek metron, which means a measure. Okay. International System of Units is how we know it today, SI. Exponentiation is a mathematical operation written as B with a superscript n, involving two numbers, the base B and the exponent of or power. So the base B and the exponent or power n. When n is a positive integer, exponentiation corresponds to repeated multiplication of the base. That is, b to the power of n is the product of multiplying n bases. Okay? So I give an example. The exponent is usually shown as a superscript to the right of the base. In that case, 10 with the superscript 3 towards the right is called 10 raised to the third power. 10 raised to the power of 3. The third power of 10, 10 to the third, or most briefly as 10 to the 3. And that's what I'm going to go with. The last one in bold, 10 to the 3, 10 to the 6, 10 to the negative 2. Okay? So the base is always 10. Let's show some examples. Exponential notation. Here you go. So we have tera with a symbol T, and the value, as you can see, the base is always 10. So this is 10 to the 12. What does the superscript 12 represents? It represents how many or the number of zeros after the 1. Not the number of zeros after the 10. That would be incorrect. Number of zeros after the 1. So it's 12 zeros. Giga, 9 zeros. Mega, 6 zeros. 6 zeros after the 1 is 1 million. Kilo, 3 zeros after the 1. And deca is 1 zero after the 1. Deci is 10 to the negative 1. Now, when you're dealing with negative integers, it's not the same. It does not mean the number of zeros after the 1. Okay, now we're going towards the left. So we're not going towards the right with the zeros like we did with the positive exponents. We're going to the left of the 1. All right, so let's go into the positives again. So 10 equals 10 to the 1, all right, which is just 10 times 1. Okay, 100 equals 10 to the 2, or just 10 times itself twice. 1000 is 10 to the 3, or 10 times itself 3 times, and so on and so forth. Okay, so now we have 10 to the 9, which is just 9 zeros after the 1, and is 10 times itself 9 times. Okay, so now 1 over 10 is just 10 to the negative 1, 1/10. 1 over 100 equals 1 over 10 times 10, or 10 to the negative 2, which is 1/100th. 1 over 1000 equals 1 over 10 times 10 times 10, or it just 10 to the negative 3, or 1,000th. And so on and so forth. Okay, so 1 over 1 million is just 1 over 10 times itself 6 times, or 10 to the negative 6, or 1 millionth. Okay, so let's go into some working examples. Where are my notes so I don't be all over the place? When you are dealing with scientific notation, it puts a limit to what happens here. Where? It puts a limit to what happens here. There. Okay, here we are. We're going to take a look at this right here. 45 times 10 to the 3. Again, what does 10 to the 3 mean? It just means 10 times itself 3 times. So let's look at it. So we have 10 times 10 times 10, and that's just 1,000, right? Hey, now another way to do this is just remember, when you have a positive exponent, you just add 3 zeros, or whatever the number the exponent is, you add those zeros towards the right. So we have the number 3 here, so it's 1, 2, 3. 3 zeros after 1 is 1,000. Okay? Here's a problem with this quote-unquote scientific notation. It's not a scientific notation because 45 is, although it's higher than 1, but it's also not below 10. Remember, a scientific notation, it has to be this number right here, 8. This number right here, it has to be above 1 but below 10. This is not below 10, so this is not a scientific notation. So this wouldn't work out. So we go 7.89, and we have a positive exponent of 5, so we are going 5 places towards the right. 1, 2, 3, 4, 5. This is our new decimal place. We have placement holders. We add a 0 in the empty placement holders. 3 zeros. And this is our new number. We have converted 7.89 times 10 to the 5th power to a number. And the new number is 789 followed by 3 zeros. 789,000. Okay, so now we have a negative exponent in our last two problems. How do you write this down? 4.23. So let's start with that. 4.23. Now this is a negative exponent, so we no longer go towards the right. We are going to go towards the left. 6 times. 1, 2, 3, 4, 5, and 6. Squeeze that in there. Boom. Placement holders, we add the zeros. 1, 2, 3, 4, 5. And our decimal is here. Okay, so how do we write this? The number is decimal 1, 2, 3, 4, 5, 4, 2, 3. Here we go. We have converted 4.23 times 10 to the negative 6 into a number. Let's move along. With these numbers, we are going to convert these into scientific notations. Okay, so it's a little different. It's a little tricky. Let's start with 1, 3, 0. Let's write the entire number. 0, 2, 3. The number has to be above 1 but lower than 10. this number, 130,023, is above 10, way above 10. So we got to make it lower than 10, but above 1. If we put a decimal point here, this number will be below 1. So we don't want to do that. Let's get that out of there. If we put the decimal point here, this would be 13, okay? That's still above 10. So we have to put the decimal point here. Now this number is above 1, 1.30023. This is above 1, but it's lower than 10. This is what a scientific notation should look like. It meets the requirements. So how many places towards the left from our original decimal point place did we go to get there? Let's count it. 1, 2, 3, 4, 5. So we went 5 places towards the left in order to get a scientific notation. So that's key, 5. So what we do is at the top, we now write our new number. It would be 1.30023 times 10, okay? And what would our exponent be? 5, because we moved 5 places towards the left to get a scientific notation. So we would go 5. Okay. So in other words, 1.30023 times 10 to the 5 equals 130,023. Okay. So let's get rid of that. This is how you convert a number to a scientific notation. You will catch on pretty fast, trust me. Now we have 0.0054. We want to convert this decimal number to a scientific notation. So the same rules apply. Okay, so we'll go 0.0054. Okay, so how many decimal places would it take to convert this number to a scientific notation? So we will have to put the decimal point here because 5.4 is above 1 and less than 10. 1, 2, 3. So it took 3 decimal places to convert this number to a scientific notation. At the top, we got 5.4. We omit these zeros. 5.4. Okay. 5.4 times 10 . Three. Hey, come on. What's going on with that? Now, would this be a positive exponent or negative? It would be negative, and I will explain why. Okay, all decimals will get a negative exponent. Okay, all decimals will get a negative exponent. So, to convert this to a scientific notation, it is 5.4 times 10 to the negative 3.